Welcome back, everybody. Today we're talking about our second geometry objective, parallel and perpendicular lines. Now, this is an important topic, not just because there's a lot of applications to it, but also a lot of the geometry we're going to look at in the future builds off the different properties, the different theorems, the different stuff we do here today. Okay, so important stuff either way. So let's get going in the note guide. First thing I want to do for you today is define parallel lines. They'll also define something called skew lines and talk about the difference. Okay, I'm going to say that parallel lines are coplanar lines that do not intersect. Okay, so lines that do not intersect. Now the key for parallel lines is this coplanar idea. In other words, on the same plane. So for example, we could say that line AD this is our parallel to symbol, parallel to BC. So AD here and BC I'd say are parallel because they don't intersect, but also they're coplanar. They're on the same plane, or they're on the same side of the box, okay, in this case here. Okay, that's opposed to skew lines, which are non-coplanar lines, okay, so not on the same plane, that also don't intersect. Okay, so for example, we could say that line AE is skew to BC. Now there's no skew to symbol here, we just say skew to. Let's take a look. AE is on the front part of the box. BC is on the top of the box. Okay, so they don't intersect, but we'd say they're skew, not parallel, because they're on different planes. One's on the front, one's on the top. They're running in different directions. Okay, so two types of lines that don't intersect. The difference is, once again, parallel are on the same plane. Skew lines are on different planes. So let's go ahead and put those definitions to use. Problem 1, identifying non-intersecting lines and planes. In other words, identifying parallel and skew lines. It says in the figure, assume that lines and planes that appear to be parallel are parallel. Part A, we want to know which segments are parallel to AB. So we have AB here, and we want to list all the segments parallel to it, so not intersecting on the same plane, or in other words, running in the same direction. Okay, it looks like DC is going to be parallel. Okay, it's not going to intersect, and it's on the top of the box along with AB. It looks like EF will be parallel as well. Okay, not going to intersect on the left side of the box with AB, again, running in the same direction. And then the other one we have here is HG. Okay, maybe it's a little bit trickier to picture the same plane piece with that one. I guess the plane technically we had would be one slicing through the box like this. Okay, but again, it's running same direction front to back on the box. Okay, that's why we know it's parallel, not skew. All right, so those are our parallel lines. Next up, we're going to do some skew lines. Okay, B asks, which segments are skew to CD? So I have CD here. And remember, skew means non-coplanar lines that don't intersect. So an example of a skew line would be AE. Okay, it's not going to intersect CD, but it's also non-coplanar. It's not on the same plane. It's running in a different direction. DC runs front to back. AE runs up and down. That's why we'd say it's skew, not parallel. Okay, we also have BF. Okay, it's running up and down. And then two more, EH will be skew to CD. Okay, it's running left to right, whereas CD is running front to back. And then the last one we have here is FG. Okay, we'd say that's skew as well. All right, so that's how to identify parallel and skew lines on 3D figures. Okay, do we solve anything here? Do we find any values? No, not really, but these are going to be important vocab words we need to be able to identify as we move through the rest of the section. Next thing we're going to talk about is the idea of lines and a transversal. Okay, I'm going to say that a transversal is a line that intersects two or more coplanar lines at distinct points. Okay, so a line that runs through two other lines. Okay, here I'm going to say that line T is a transversal because it intersects lines L and M at specific points here. Okay, now if I extended lines L and M out here, they'd intersect as well. Okay, we could look at these different lines as transversals with each other. We'll focus on T here. And the reason we're going to talk about lines and a transversal is when I make a transversal, notice I get a bunch of different angles. I get 8 of them here. What we're going to do is we're going to give each of those types of angles a name and then look at how they relate to each other when we have parallel lines in our plane. Okay, so we're going to give you 4 types of angle pairs formed by lines in a transversal. First one is going to be alternate interior angles. We'll say they're non-adjacent interior angles on opposite sides of the transversal. Okay, so when I have my transversal in the 2 lines, it's going to split the plane into the interior and exterior. We'll say the interior is everything on the inside, everything between those 2 lines. So we have interior angles on opposite sides of the transversal. So for example, we could say angles 3 and 5 are alternate interior angles. Okay, opposite sides of the transversal, interior in between the lines. The other pair we'd have would be 4 and 6, they're alternate interior as well. The next pair we have is same side interior angles. We'll say they're interior angles on the same side of the transversal. Now I goofed my color coding up here, but we'll make this work. Okay, so for example, angles 4 and 5 would be a set of same side interior. Again, they're on the interior, they're in between the lines, but they're on the same side of the transversal, they're both on the left. Okay, 3 and 6 would be my other pair here. Okay, again, same side of the transversal on the interior. Okay, we're also going to talk about corresponding angles. We'd say they're angles that lie on the same side of the transversal in corresponding positions. So for example, angles 1 and 5 would be corresponding because they are both on the same side of the transversal to the left. Try that again. Same side of the transversal to the left, and they're both above the line of intersections. We can say they're both in the upper left. Okay, 2 and 6 would also be corresponding angles. They're both on the upper right. Okay, or 3 and 7 would be both corresponding angles, both on the lower right. Okay, or we could say 4 and 8. Okay, so that corresponding idea just means the same position on the intersections. And then the last set we have are alternate exterior angles. We'll say they're non-adjacent exterior angles on opposite sides of the transversal. Okay, so for example, 1 and 7 would be alternate exterior because they're outside the 2 lines, they're above and below, and then once again, they're on opposite sides. Okay, same thing with 2 and 8, opposite sides of the transversal on the exterior. So let's go ahead and practice using those definitions here. Okay, and we'll run through all these together. First part A, name all pairs of corresponding angles. Okay, now anytime we have 2 lines in a transversal, so we have our lines M and N and the transversal R that runs through them, we're going to get 4 sets of corresponding angles. So for example, angles 1 and 3, let's go ahead and practice using those definitions. Okay, problem 2 part A says name all pairs of corresponding angles. Now, anytime I have 2 lines, such as M and N, with the transversal R here, we're going to get 4 sets of corresponding angles. And remember, corresponding are the ones in the corresponding positions. So for example, angles 1 and 3. We'd say are corresponding. Okay, they're both to the left of the line they intersect and above the transversal. They're both on the upper left. Okay, we could also say that angles 2 and 4 are corresponding. They're both on the upper right. Same idea, we could say that 8 and 6 are corresponding. They're both on the lower left. And then the last ones we have are 7 and 5. Okay, both on the lower right. Okay, so we're looking for corresponding angles. Again, you're looking for angles in the corresponding positions of those intersections. All right, next thing we're going to look at are same-side interior angles. Okay, the name really describes how these work. Okay, same side and interior. So for example, here we could look at angles 2 and 3. They're on the same side of the transversal. They're above the transversal. And they're also on the interior of the lines. They're between the two lines, M and N. That's why we'd say angles 2 and angle 3 are same side interior. Okay, our other pair then would be 7 and 6. Okay, they're also on the same side of the transversal on the interior. That'll be it for that one. We'll get 2 sets of same side interior angles anytime we have 2 lines in a transversal. All right, moving on to C and D, we're going to do the same thing with alternate interior angles. Okay, here I'd say that 2 and 6 are alternate interior. Okay, they're on alternate sides of the transversal. One's above, one's below. And again, they're on the interior of those lines. They're both between the lines. And my other pair would be 7 and 3. We say they're alternate interior as well. All right, last pair we're going to look at then are alternate exterior. Okay, alternate exterior would be on alternate sides of the transversal, but this time on the exterior, so outside of those lines, the transversal intersects. Examples of those would be 1 and 5. Okay, again, one's above, one's below. That's our alternate piece. And then for the exterior, they're both outside of those 2 lines. So we'd say 1 and 5 are alternate exterior. Okay, our other set then, our last set would be 8 and 4. And what we see here then is that we get 2 sets of alternate interior and 2 sets of alternate exterior as well anytime we have our 2 lines and our transversal. Okay, next problem, we're going to do the opposite. Okay, here we'll give you the angle pair. You've got to classify them. And there's a few parts of this. We'll do A and B together. We'll have you try C and D on your own. Okay, so classify each angle pair. For part A, we want to look at 3 and 5. Okay, well, what are 3 and 5? Well, they are on the same side of the transversal, so they could be corresponding, they could be same side interior, but they're both between my 2 lines here. All right, so that's why I'd say they're same side interior. Okay, same side interior angles. All right, next up for B, we've got 3 and 6. So angle 3 is here, angle 6 is here. Now these are on the interior as well, but they're on alternate sides of the transversal. So that's why I'd say that 3 and 6 are alternate interior angles. Okay, so there's 2 examples of classifying the angle pairs we're given. All right, C and D is the same idea, same picture. Why don't you take a minute here, pause the video. Okay, classify the angle pair for C and D. Okay, throw your hand up in the air, check your answer before we move on. And then once you've checked, once you make sure you're good with this, you can continue with the notes. Now, the reason that we named all those angle pairs is that there's going to be some certain properties we know about them. Okay, measurements we're going to be able to find when we have parallel lines with my transversal. Okay, so what I have are 4 sets of properties, or 4 theorems for you. The first one, I suppose, is not a theorem, it's a postulate. It's the corresponding angle postulate. And it says that if a transversal intersects 2 parallel lines, then corresponding angles are congruent. Okay, so if we have our transversal, our 2 lines, and those 2 lines are parallel, so if line L is parallel to M, then what we get is all our sets of corresponding angles would be congruent to each other. They'd have the same measure. So in this case, I know that angle 1 is congruent to angle 5, 2 is congruent to 6, 3 is congruent to 7, 4 is congruent to 8. Okay, all those pairs of corresponding angles are congruent. All right, let's go ahead and use that postulate then. Okay, identifying congruent angles. Problem 4, part A asks, which angles measure 55 degrees? How do you know? Okay, well, I'm given 55 degrees here, kind of in the lower right of my first intersection. And I know that the 55 is going to be corresponding with angle 7 here. Okay, we just said since these lines are parallel to each other. Okay, I forget if we mentioned earlier, but these same number of arrows on a line mean they're parallel. Okay, since they're parallel, we know they're congruent. So I know that angle 7 will be 55 as well. Okay, the next up, what other angles do I know are 55? Well, angle 1 here is vertical with this original 55. So I know it's got to be congruent as well. We know that vertical angles are always congruent. Okay, and then angle 1, notice it's corresponding with angle 5 here as well. Or we could think about angle 5's vertical with angle 7. Either way, we know that's going to be 55. Okay, so what I get then, anytime I have a transversal with parallel lines, are going to be 4 angles that are all congruent to each other. Okay, based on what we know about vertical angles, then also that corresponding angle postulate we just gave you. Okay, problem 4, part B is the same idea. Once again, why don't you take a minute, pause the video, work through that one, and then throw a hand up in the air, get your answer checked before we move on. All right, so we have our corresponding angle postulate. We're also going to give you a theorem or a property for each of those other sets of angle pairs we gave you a few minutes ago. And they're all going to hold true when we have a set of parallel lines with our transversal. Okay, first one's the alternate interior angle theorem. It says that if a transversal intersects 2 parallel lines, so again, we have transversal with parallel lines, okay, then alternate interior angles are congruent. So in this case, angle 4 would be congruent to angle 6, and angle 5 would be congruent to angle 3. So we have alternate interior angles are congruent. All right, we also have the same side interior angle theorem. It says that if a transversal intersects 2 parallel lines once again, okay, then same side interior angles are supplementary. So my color coding's off here again. But what I have then are same side interior angles, such as 4 and 5 will be supplementary. As when I add them together, the measure of angle 4 plus the measure of angle 5 is going to equal 180. Okay, same thing with my other set of same side interior angles, 3 and 6, they'd be supplementary as well. They'd add to 180. Okay, then the last one we have is the alternate exterior angle theorem. It says, again, if a transversal intersects 2 parallel lines, then alternate exterior angles are congruent. So as in 1 and 7 would be congruent to each other. Again, alternate sides of the transversal on the exterior, as well as angle 2 and angle 8 would be congruent. Okay, so running through those again quick, we said we have the corresponding angle postulate that said that corresponding angles are congruent when the lines are parallel. We also know that alternate interior angles are congruent. Same side interior angles are supplementary. That's kind of the one different one here. And then also alternate exterior angles are congruent. All right, so let's go ahead and use those properties to find some different angle measures. All right, problem 5, find the measure of each angle. We've got A and B here, and there's a C and D we'll have you do on your own. Okay, so here notice we have two sets of parallel lines. L and M both have one extra arrow on them, so they are marked parallel to each other. And same thing here, I know P and Q will be parallel as well because they both have two sets of arrows. Okay, let's start off by looking for angle 3. Okay, how does 3 relate to what we have in the problem? Well, 3 and the 105 we're given are alternate interior angles. They're on alternate sides of my transversal M, okay, and both on the interior, they're between the other two lines that intersect. We know that alternate interior angles are congruent when those lines are parallel. That's why we know that angle 3 is equal to 105 degrees as well here. Okay, for angle 4, now as far as how angle 4 and the original 105 were given relate, okay, I'm going to say they're same side interior because they're on the same side of this transversal Q, and they're both between the lines L and M. Okay, we know that same side interior angles are supplementary, so to get angle 4, what we can do is we can take 180 degrees and subtract the 105, which gives us a 75 degrees for angle 4. All right, so that's how I can use those different theorems to solve for angle measures when I have parallel lines in a transversal. Okay, there's also a C and a D here. Why don't you take a minute, once again, pause the video, work through those two, and then check your answer before you move on. All right, problem 6 deals with the same theorems. Here we're just going to add some algebra and some problem solving to the mix. Part A asks, what is the value of x for which A is parallel to B? In other words, what x value, what numbers do I have to put in these two angles here to make A and B parallel to each other? Okay, so in other words, to satisfy those different theorems or properties we just gave you here. Okay, well, let's think about what type of angle pair we're looking at. The angle with the 2x plus 9 and the 111 are same side interior angles once again. And we know when the lines are parallel that same side interior angles are supplementary. So the equation I can set up for this one to solve for the x would be I'd add the 2x plus 9. All right, plus the 111. We know again they'll be supplementary, so we can say is equal to 180 degrees. Okay, angle plus the other angle equals 180. And again, we know that's true because we're looking at same side interior angles. All right, we can solve this equation then. To do that, we'll combine like terms. 9 plus 111 is 120. So we can say that 2x plus 120 is equal to 180. And then to get the x by itself, we can subtract 120 on both sides of this equation. That's going to give me that 2x is equal to 60. And then divide both sides by 2 to get the x alone. That'll leave us with x equals 30. All right, so when x equals 30 degrees, we can also figure out what this angle is going to be then. Okay, 2 times the 30 plus the 9, so in other words, 69 degrees. When this angle is 69, that's going to make these two lines parallel to each other, because again, it's going to satisfy our same side interior angle theorem property. Okay, now with problems like this, it won't always be equal to 180. In some cases, we'll set the angles equal to each other. Okay, part B is the same type of question. Why don't you take a minute, once again, pause the video, work through that one, and then check your answer before you move on. All right, moving along. Problem 7 asks us to identify parallel lines. Part A asks which lines are parallel if angle 1 is congruent to angle 2. Okay, so again, like we saw a few minutes ago, we've got a mess of different intersecting lines, okay, a bunch of different lines and transversals. And we want to decide if we know that angle 1 is congruent to angle 2, okay, which lines, if any, have to be parallel. Okay, well, angles 1 and 2 are both hooked onto this line M here. So we can think of M as our transversal with lines A and B as the lines they intersect. Kind of missed line A here, but oh well. Okay, and what are angles 1 and 2? Well, they'd be corresponding angles. They're both on the upper right part of that intersection. Okay, so here I have corresponding angles that are congruent. That means the lines the transversal intersects have to be parallel. That means in this case I'd have A is parallel to B. Okay, if I knew that 1 and 2 are congruent, that means that A and B have to be parallel. All right, problem 7, part B is the same idea. We'll give you some different properties. Once again, take a minute, pause the video, work through that one, and then check your answer before we move on. All right, then last set of problems for this lesson. Okay, here we're going to be looking at the relationship between parallel and perpendicular lines. So let's take a look. Part A says that in the plane, this is going to be the perpendicular to symbol, perpendicular to B. Line B is perpendicular to line D, and line D is perpendicular to line A. Okay, what do you know about the relationship between C and A? Okay, so in other words, how are all these lines going to relate to each other? Okay, now this might look like a mess, but once we start drawing a picture of it, it's not too bad. Let's start off by just drawing two lines, C and B, perpendicular to each other. Okay, so I'm going to make a set of lines that intersect at a right angle. And now it doesn't matter if I call this one C or this one C. Okay, I'm just going to say C and D like so. As long as I draw them perpendicular to each other, we'll be able to answer this question. Okay, next thing we have is that B is perpendicular to D. So we can draw a line B here anywhere we want in this picture as long as it's perpendicular to line D. Here's D, so we'll make our B once again intersected at a right angle. And then finally we'll say that D is perpendicular to A. So once again here we'll draw a line A in here perpendicular to the D. Oops, we want that to be A. Make it look a little more like an A there. Okay, so we've drawn out the situation, and we want to know again, how does A and C relate to each other? So kind of our first line and our last line here. Well, what it looks like is true is that C and A are going to be parallel to each other. And we know that's going to be true for a fact is because if I look at D as my transversal with A and C as the two lines, we have corresponding angles that are both 90, okay, meaning those two lines have to be parallel. So here we can say that A is parallel to C. Okay, the nice thing is when we're dealing with lines that are only either parallel or perpendicular, okay, the answers are always going to be parallel or perpendicular when it's all said and done, and that's going to be based on the different properties we looked at. Okay, when you get a messy situation like this, draw things out, and you'll be able to see pretty easily with that picture, okay, how those lines relate to each other. All right, so last thing for you then, there is a part B to this one. Once again, pause the video, run through that one, and then check your answer before you move on to your Math Excel practice.